All right, now we're going to look at question numbers 4 through 6. All right, on question number 4, it doesn't sound like we're not doing one that sounds like a game. Okay, I just wanted to show you a variety of problems where expected value can be used. All right, so here we have in a math class, we have probabilities that have been determined through experimenting, through looking at data for the number of absences to expect or the number of absences on any given day. So the probability there will be no absences is 18%. One absent, 26%. Two absences, 29%. Three absences, 23%. And four absences, 4%. All right. And then the question is to find the expected value, expected number of absentees on a given day. Give the answer to 2 decimal places. How many students would you expect to be absent on a given day? All right, so what you're going to do is take the number absent times the probability that would happen, plus the number absent, that if one person's absent, the probability would be 0.26, plus 2 people absent times the probability of that happening, 3 people absent times the probability of that happening, 4 people absent times the probability of that happening. Okay? All right, and then you would use your calculator to add all of that up. And when you do, you wind up with 1.69. So the expected value would be that we'd have 1.69 absentees on any given day. Okay? That would be the answer. All right, now 5 and I believe also 6 are kind of more game-like, but they're raffles, okay? So here we have a college foundation that's raising funds by selling raffle tickets for a new car worth $36,000. 600 tickets are sold, and they're sold for $120 each. And we're supposed to determine the expected net winnings of a person buying one of the tickets. So let's just do this in order. So let's look at A. Expected winnings of a person buying one of the tickets. Okay. So the expected winnings. All right. So we have we bought one ticket. There's 600 sold. So the probability that we win is 1 out of 600. Okay. And then the value of what we win in this case would be $36,000. All right. Now, okay, we don't really need to do that. All right, and then that would turn out to equal 60. All right, so those would be like your expected winnings. But if you want to do expected net winnings, don't forget you paid. That's your expected winnings, but you paid $120. So your net winnings would be negative 60. Okay, so that would be negative $60. Okay. All right, now B says if the game is fair, to determine if the game is fair or if it's unfair against the player or unfair in favor of the player. So it's unfair against, isn't it? Unfair against, since net winnings are negative. So unfair against the player. Now, that choice. All right, then we're being asked to think about what's the profit the foundation makes, because of course they do this to raise money for some good cause like scholarships for students. All right, so in C, we're figuring the total profit, assuming they had to actually buy the car. Okay, so what you could do for that would be the fact that they sold 600 tickets and they were $120 each. Okay, so that would be 7,2 2, 3, $72,000, okay, is how much money they brought in. But if they had to buy the car, then we need to subtract that $36,000 for the car, and they'd wind up with a profit of $36,000. So that would be the profit. If they had to buy the car, their profit would be $36,000. All right, but now if the car was donated, right, then you don't have to subtract that $36,000 off of there. And so the profit for the foundation would have been, they would get all the money from those raffle tickets, which would be $72,000. Okay, so not too shabby. So D would be the whole $72,000 would be theirs. They didn't have to buy the car. Okay. All right, so let's look at question number 6. So this one's also a raffle. So this one has that 5,000 raffle tickets are sold. Okay, and first prize is $1,000. Second prize, you get 2 of those, and they're $500 each, and 3 third prizes of $100 each. And the winners are selected randomly. So these 5,000 raffle tickets that were sold are all in a bag, and you're just gonna pull out these winners. Okay. And it says if you purchase 1 ticket, what are your expected gross winnings? Okay. So we have a 1 out of 5,000 chance of getting first prize, which would be $1,000 if we did that. Okay. For second prize, we have a 2 out of 5,000 chance of that happening. That's supposed to be 1,000 for first prize. Okay. And so for second prize, we get 500. And for third prize, we have a 3 third prizes. So we have 3 out of a 5,000 chance of getting a third prize, and that would be 100. All right, so for part A, what we would do is the expected value calculation. So we'd have 1 out of 5,000 chance of making 1,000 plus a 2 out of 5,000 chance with a payoff of 500 plus a 3 out of 5,000 times a payout of 100. All right, and so let me simplify those, but let me not simplify it too much. It might be easier to calculate for me. Nah, just use your calculator. This would be 1,000 over 500, so that'd be like a fifth. 1,000 over 500 would be another fifth. 300 over 5,000 would be 3 out of 50. And if I do all of that, I wind up with 0.46. If I just do it on my calculator, let it do it for me and get the decimal, I get 0.46. So that's like expected gross winnings would be 46 cents. Okay. We don't know, let's do it in dollars. 0.46, 46 cents. Okay. Less than $1. All right. Now it says if the tickets were sold for $1 each, how much profit goes to the raffle sponsor? $1 each, how much profit goes to the raffle sponsor? Okay, so let's think about that. So the expected value would be 46 cents. Okay, so your expected value is 46 cents, but you paid $1. So that would mean that you're paying 54 cents. You're owing 54 cents. So that 54 cents times those 5,000 raffle tickets means that they would be expected to get $2,700. So they would get a profit of $2,700. Now on C, it says, was $1 a fair price? Well, remember, your net winnings should be 0 if it were a fair price. So not fair, unfair. And it's unfair against, right, the player. And then it says, if not, what is a fair price? Fair price would be 46 cents, wouldn't it? Because then your net winnings would have been 0. The net winnings would have been 0. Okay. All right, let me go ahead and squeeze in one more question on this video so I don't have to post another one. I don't like them to get too long because I know they're harder to open and watch and all. All right, let's do that there. All right, so let's just think about how expected value can be used, kind of like on that problem where what was the expected number of absences you would have in a class. Okay. All right, this problem deals with business decisions you can make by trying to apply expected value in those situations, because it works. It works to apply these ideas to business and insurance and other contexts. All right, now we're going to look at a situation, and we're going to look at using what we just learned about, use the expected value to figure out which project to go with. But then we're also going to go and look at, well, what would an optimist's viewpoint, like what would they choose if they're an optimist, and what would they choose if they're a pessimist? So we'll do that too. Because sometimes instead of using expected value, people will use one of these other ideas, like the best case scenario. And with a pessimist, it would be looking at the worst case scenarios and taking the best out of all of those. Okay, so first let's do expected value. So here we have some projects, and so Lori is a building contractor, and she's going to decide which of these projects to choose. So if she decides that she's going to use expected value, what she would want to do would be to calculate the expected value for each of the projects. So she would multiply these quantities together that we see for project A, 60,000 times 0.10, 180,000 times 0.60, and then 250,000 times 0.30. So there's like a 60% chance they would make 180,000, a 30% chance they would make 250,000, and a 10% chance they would make just 60. Okay. And so what you would do is do those products and then add these together. So then add it all up, and you'd wind up, if you did that, with 189,000 as the expected value for project A. So the expected value would be that you'd make a profit of 189,000. So do the same on these others. Take 0 times probability of 0.20, 210,000 times 0.35, and 290 times 0.45, and then add all those up, and you wind up with 204,000 as the expected value. So you could expect to make 204,000. And then on project C, do 40 times 0.65, 340 times 0.35, and add those up, and you'd wind up with 145,000 as the expected value. So if she's going to pick the project based on expected values, then she should pick the project that has the highest expected value, and that would be project B. That's what she should go with. Okay, but rather than using expected values, she might be taking the optimist viewpoint. Well, with which of these projects do you have the possibility of making the most money? Okay, so the most you can make on project A is 250. Project B, the most you can make is 290. Project C, she's estimated the most she could make would be a profit of 340,000. So if she's going to use the optimist viewpoint, then she should go with the project that has the possibility of making the most. That would be project C. Okay. All right, now let me change to green. All right, and then the pessimist viewpoint would be, let's not risk losing very much money. So look at the worst cases. With project A, the worst case scenario is still a profit. It's a profit of 60. Project B, it could be that you do all this work and you really don't make any money, but you're not in the negative either. And then project C, the worst case scenario is that you would make just 40,000. So the pessimist viewpoint would be looking at worst case scenarios and taking the best of those. So if she's going to use that idea, she would go with project A. And that's because it's the best. It's the best of the worst case. And on the other one, it was the best of the best case. That's the optimist, is the best of the best case. All right. So that's it. That's the expected value ideas. Get going on that homework and be ready to take that quiz on that.